in all its glory. Now if we notice, this ratio here for the midpoint rule is about a quarter. So if we assume that that particular pattern repeats, i.e. the ratios that we're going to get the differences are going to continue to be a quarter, we can actually exploit that particular thing to get an extrapolated estimate. Now the difference between that difference when divided by 4 becomes 18. So this difference here will be a quarter of that number there. And we can now work out the other differences, which means that the estimate for M16 should be the estimate we had for M8 plus the difference we should get. So that now gives us M16. We can work out M32, M64, 128 and so on. And to show that we're only doing an estimate, we put quote marks around the M's. So I'm only going to fill out up to M3048. You should fill out all of these. So we've now got an extrapolated estimate there. We can do the same thing with the trapezium rule. We can fill out the fact that the ratio should be a quarter, that the differences should reduce by a quarter each time, and we can now work out T32, and we can extrapolate that estimate, again putting in the fact that these are only estimates of what we expect the real answer to be. Similarly, we can do the same thing with Simpson's rule, but this time the ratios go down by a 16th. So now that difference will be the previous one times a 16th. So S16 will be that plus that number there. And again, we write in S16 in quotes to show it's only an estimate. Again, these should be filled out completely and fully to ensure that you have got an accurate spreadsheet. Now, you need to work out the value of your integral to 6 decimal places. At the moment, we don't get agreement of these answers to 6 decimal places. To get a better extrapolated estimate, we need to work out, for example, M16 exactly, M32 exactly. Rather than assuming the pattern continues, work those out exactly, which then allows you to get better trapezium rule estimates, which allows you to get better Simpson's rule estimates, and hence better extrapolated estimates. You're aiming for those extrapolated estimates to agree to 6 decimal places.